Hello, this is Dr. Hanaa Assil, and today we're doing June 2021 Unit 2 Edexcel Chemistry, and we will discuss the answers. So the first question in this exam was, which is the correctly labeled reaction profile for an exothermic reaction? First of all, you should remember in an exothermic reaction, reactants give out heat or give out energy, and that means the products have to be lower energy than the reactants. So C and D are not exothermic, they are endothermic. So we are choosing between A and B. Okay, what is the difference between A and B? The labeling of the delta H and the energy of activation. Which one is delta H and which one is the energy of activation? You should remember that. From reactants to the top is energy of activation. From reactants to products, it's delta H. So B is wrong. The equation for a reaction is this. What is the correct symbol for the enthalpy change for this reaction? Well, let's see. The first choice is delta H of atomization. Is this delta H of atomization? It is not. Atomization means breaking up a molecule into atoms in the gaseous state. So this is not atomization. Delta H of combustion. Well, what is delta H of combustion? It is the energy change when 1 mole of a substance, so I should have 1 in front of the C, not 2. 1 mole of a substance is burned in excess oxygen in its standard state. So that is not delta H of combustion because he has 2 moles of carbon. Delta H of formation, is this formation of something? Well, formation also, for example, this is an example. Formation means we're forming 1 mole. So it is the energy change needed to form 1 mole. The reaction that we have on top here is forming 2 moles. So this is not called delta H of formation. It is not called delta H of combustion. It would be delta H of reaction. The third question says the graph shows how the concentration of iodine changes with time in a reaction. What is the value for the rate at 8 seconds? Remember that 8 seconds, okay, this is 8 seconds, but how do we get the rate? The rate is the slope at that point. So how do we get the slope at that point? The slope will be the change in the x-axis, the y-axis over the change in the x-axis. So you want the change in concentration of iodine over the change in time, which is the 8 seconds. So that means that the rate is A. Okay. The solid line on the graph below shows the Maxwel-Boltzmann distribution for an uncatalyzed reaction. EA is the activation energy when there is no catalyst. So which row shows the correct Maxwel-Boltzmann curve and activation energy for a reaction at higher temperature and with a catalyst? First of all, if my bold line or solid line is my original graph, now when I increase the temperature, will it be X or Y? Remember that when we increase the temperature, the graph shifts to the right and the maximum is lower. So actually it is Y when I have higher temperature. So when I have a catalyst, what happens to the activation energy? You should remember that the activation energy moves back towards the left. So W would be your activation energy when we use a catalyst. So the answer is C. What is the oxidation number of chromium in this compound? Well, let's sit down and calculate it. You should realize that sodium is in group 1. We have 2 of them, so that's +2. Chromium, I have 2 of them, so that is 2x that I don't know. Minus the oxygen. Oxygen, each of them is -2. I have 7, so it's -14. All of this overall should be 0. Calculating for x, x comes out to be +6. In an oxide of nitrogen, the oxidation number of nitrogen is +4. So which of these has oxidation number +4? You should know how to calculate oxidation numbers. Now, For A, for example, in all of these cases, each oxygen is -2, and the overall is 0. So in A, for example, we have 2x minus 2 is 0, so x comes out to be +1. In the second one, I have 2x minus 6 is 0, so x comes out to be +3. In the third one, I have 2x minus 8. Each oxygen is -2, and that is +4. This one is +5, so he's saying which one is +4, so that is C. Are we following all of this? Please try and remember all of these information. Hydrogen peroxide breaks down into water and oxygen in terms of oxidation and reduction. How do hydrogen and oxygen change in this reaction? Well, let's see. You remember that hydrogen peroxide, when it breaks down, it forms water plus oxygen, and this is the balancing of it, which doesn't make a difference with us. Anyway, so we're looking at what has happened to the oxidation number of hydrogen and oxygen. Now, you should realize that in both cases, hydrogen is +1. It hasn't changed. But if you calculate the oxidation number of oxygen in H2O2, the overall is 0. If 2 hydrogens are +2, then the 2 oxygens, each of them has to be -1. Now, in water, the oxidation number of oxygen is -2. When it is an element, O2, we said oxidation number of any element is 0, and that means that the oxygen has changed from -1 to -2. That is reduction. From -1 to 0, that is oxidation. So my answer must be D, in which the hydrogen is unchanged, but the oxygen has both been oxidized and reduced. Several factors may affect ionization energies, and he's saying which factors explain the decrease in ionization energy as group 1 is descended. So we're looking at group 1. We're looking at what happens to the ionization energy in group 1 as we go down. You should remember that the first ionization energy of the elements in group 1, as we go down, the ionization energy decreases. Now, why does it decrease? That's what he's asking. So he's saying, okay, is it because the number of protons increases? Well, the number of protons does increase as we go down, but that is not why the ionization energy is decreasing. What about in the second one? The outer electron is further from the nucleus? Yes. Remember, what is ionization energy? It is the minimum amount of energy needed to remove the outermost electron. So as we go down the group lithium, sodium, potassium, that outermost electron we're trying to remove is further away from the nucleus. So there is more shielding, so the amount of shielding increases. And that is why the amount of energy needed to remove that outermost electron is decreasing. It is not because number of unpaired outer electrons increases. That has nothing to do with it. So my answer will be B. Separate samples of some halogenoalkanes were dissolved in ethanol and a few drops of silver nitrate solution. The faster the reaction of the halogenoalkane, the quicker a precipitate forms. Which of these halogenoalkanes reacts the fastest? So he is asking, which of these reacts the fastest? Well, what is the difference between all of these? The first one is iodopropane, bromopropane, chloropropane, fluoropropane. So the difference between them is the halogen that is attached to them. And you should remember that as we go down the group fluorine, chlorine, bromine, iodine, the atom becomes bigger, so the bond becomes weaker. Remember that the bond between the C and the halogen becomes weaker as we go down. So which one will break the fastest? It is the Ci that will break the fastest. So my answer is the first one. Remember that as we go down, group 7, the bond between the atom and carbon, for example, becomes weaker since the atom becomes larger and there is less attraction between the positive nucleus of the iodine and the bonding pairs of electrons. So the bond is weaker and it can be broken fast. Which of these halogenoalkanes reacts the fastest? Again, let us take a look. In order to compare them, I need to draw them. So let's draw each of these. This is A and B and C and D. So the difference between them is the type of halogenoalkane. All of them are bromines, so that has nothing to do. But which type of halogenoalkane is each one? The first one you should realize is a secondary. The second one is a tertiary, then a primary and a primary. Now, which one breaks fastest? You should remember that a tertiary is the one that reacts fastest because it will be removed and it will form a tertiary carbocation. This is a faster reaction than if it were a secondary or a primary. What is the structure of 2-bromo, 3-chloro, 2-methyl butane? So we're looking at each of these and we're seeing which is the compound he's looking for. Okay, if you look at the first one, actually, you would find that, okay, this is 1, 2, 3, 4. So remember that you take the longest chain. So this is 4 carbons, so this is butane. And then if I number them from the left, then the bromo is on carbon number 2, the chloro is on carbon number 3, and I have another methyl group on carbon number 2. So that actually is my compound. If you look at all the others, you will find that they're not correct. Which structure represents a primary halogenoalkane? Again, a primary halogenoalkane means the halogen is attached to a carbon that is attached to only one carbon. So which of these has the halogen attached to a carbon that has only one carbon? So that is C. Okay. Which could be the infrared spectrum of this compound? So he's looking for something that has an OH, that means an alcohol with an OH, and alkene with a C double bond C. Now, usually you would have your data booklet with you, but just looking at them, well, okay, first of all, B and D are out because B and D do not have peaks for OH. Remember, the peak for the OH is the one that is broad at 3000 and something. So A and C have a peak for OH, but then I also need a peak for the C double bond C. If you look at your data booklet, you will find that that peak there in band in about 1600 and something, that is the peak for C double bond C. The other one, A, doesn't have it, so that is my required spectrum. The mass spectrum of propanone is shown. Do we know how to draw propanone? Prop means 3 carbons. On means it has a ketone. A ketone is a double bond O in the middle of a compound. So it's a double bond O in the middle, and I have a total of 3 carbons. So that is the structure of propanone. Now he's saying which fragment is most likely to produce the peak at 43. Okay, let's try and cut it into pieces and see which one is 43. Well, if you cut that piece out, the CH3CO, that will come out to be a mass of 43, so that is the one we're looking for. Okay. A 4 mole per decimeter cube solution of an acid is used to prepare dilute solutions of the acid. What volume of water is required to make up 150 centimeter cubed of 0.35 mole per decimeter cubed solution? Okay, so I want a solution with a total volume of 150, and the concentration should be 0.35, not the 4 that he's starting with. He's starting with a solution that is 4 mole per decimeter cube. I want it to be 0.35. So first of all, the first thing we usually do is get the number of moles in that required solution. The number of moles in the 150 centimeter cubed of 0.35 would be concentration times volume. The concentration is 0.35. Do not forget to divide the volume by 1000 to change it from centimeter cube to decimeter cube. So that is the number of moles that we want. Okay, That means I need to determine what is the volume of that original solution with the 4 mole per decimeter cubed concentration. What volume should I take from it to have this number of moles? So volume is number of moles over concentration. I want that number of moles, and the concentration was 4. So we need 13.1 centimeter cubed from that original solution. But then I want a total of 150 centimeter cubed. So if I take 13.1 centimeter cubed of that 4 mole per decimeter cubed solution, I need to add to it how much water. I need the total volume to be 150. So I will need to add 136.9 centimeter cubed to the 13.1 in order to make a total of 150. Okay, the next question says a pellet of sodium hydroxide has a mass of 0.7 grams. Some pellets were dissolved to make 350 centimeter cubed of 0.25 mole per decimeter cubed solution. How many pellets were dissolved? Okay, how many pellets were dissolved? I need to find out number of moles first. So number of moles is concentration times volume. Again, the volume divided by 1,000. So that gives me the number of moles. Then I need to change that into a mass. So the total mass that I need for that solution is number of moles times mR, and he gives me the mR. And that means that I need 3.5 grams of the sodium hydroxide. So if each pellet is 0.7, how many pellets will I need? I divide the 3.5 by the 0.7, and that says that I need 5 pellets. Then he continues the same question and says he has 25 centimeter cubed of that sodium hydroxide solution. It was placed in a conical flask and titrated with sulfuric acid. Calculate the number of moles of sulfuric acid that reacted. Okay, we need a number of moles of the sodium hydroxide. The number of moles of sodium hydroxide is the concentration times volume. We already have the concentration in the previous question. It was 0.25, and the volume is the 25 centimeter cube divided by 1,000. That gives me the number of moles. And then I look at the equation. The equation says the number of moles of sulfuric acid is actually half of the number of moles of sodium hydroxide. 2 of sodium hydroxide reacts with 1 of sulfuric acid. The number of moles of sulfuric acid would be the number of moles of sodium hydroxide divided by 2. That is the one he wants, so that is the answer in A. Then he says phenolphthalein indicator was used for the titration. What was the color change? Remember, he had the base in the flask, and when we add phenolphthalein to a base, it is pink, and then it changes to color. Do you remember these colors? We should remember all the information that we have in O-level and in Unit 1 and Unit 2 and Unit 3. Okay, the next question says, which silver halides are soluble in concentrated aqueous ammonia? Remember, silver halides is when I'm testing with aqueous silver nitrate. We said if I add aqueous silver nitrate to a compound that has halides, the chloride gives white, bromide gives cream, iodide gives yellow. Now, which of these are soluble in concentrate? Remember that we said chloride is soluble in dilute, but if it is soluble in dilute, it is also soluble in concentrate. Bromide is soluble only in concentrated. Iodide is not soluble in dilute or concentrated. So the ones that are soluble in concentrated are both chloride and bromide. What volume in decimeter cubed of hydrogen gas will be produced when 3 grams of lithium is reacted with water and room temperature and pressure? That means we can use the equation that has 24 in it. Okay, so he's asking for volume of hydrogen, but he gives me 3 grams of lithium. So the first thing I need to do is get the number of moles of lithium. Number of moles is mass over molecular mass. So that gives me a certain number of moles. Then I look at the equation and I compare where is lithium and where is hydrogen. Well, lithium is twice hydrogen. That means if I'm looking at number of moles of hydrogen, I need to divide the number of moles of lithium by 2. So that gives me the number of moles of hydrogen. Now I can get volume using which equation? Volume is number of moles times 24. So that gives me 5.22. Then we go into the second section where you have short answers. The first question says 1 bromopropane is used for spot removal when dry cleaning clothes. 1 bromopropane does not occur naturally but can be made from propane 1-all. Identify the reagents you would use to make 1 bromopropane from propanol. So you're trying to replace an alcohol with a halogenoalkane. Which reagents should I use to replace the OH with a Br? Remember, you should have concentrated sulfuric acid and potassium bromide solution. Then he has several reactions and he's saying the 1 bromopropane, he's trying to change it into propene. And he already tells you that I need to add potassium hydroxide. So we're doing this to a bromopropane and we're trying to do elimination reaction. We're changing the bromopropane into an alkene. Remember that we said the potassium hydroxide, if it is in water, it will just replace the Br with OH. But if I wanted to do this elimination reaction, then it has to be alcoholic potassium hydroxide or in presence of ethanol. Okay, the next question says, give the molecular formula of product B. What is product B? Product B is when I change the bromo propane in reacting with potassium cyanide. That means I am replacing the Br with a Cn. So basically, he's asking you for the molecular formula of that product. Well, I have C4H7N because this gives the cyano product. Then he says, name the type and mechanism of the reaction taking place in reaction C. Where is reaction C? Reaction C is bromopropane changing into propanol, replacing the bromine with an alcohol. This is nucleophilic substitution. Complete the mechanism for the reaction that occurs between ammonia and 1 bromopropane to form the propyl amine. So what are we attacking here? We're using the ammonia, the NH3 with its lone pair of electrons to attack the carbon next to the bromine. This is because the carbon has a slightly positive charge and the bromine has a slightly negative charge. Remember the curly arrows. Then when we add the ammonia, so now we have the ammonia instead of the Br, we remove that extra hydrogen, so it forms the amine, and my other product would be ammonium bromide. Write an equation for the reaction. Magnesium reacts with sulfuric acid. So he just wants a normal equation and he needs to include state symbols. So we have magnesium plus sulfuric acid to give magnesium sulfate plus hydrogen. Remember, magnesium is a solid, the acid is aqueous, the magnesium sulfate is aqueous, and the hydrogen is a gas. Then he says a student carried out an experiment to determine the enthalpy change of this reaction. A sample of 0.5 grams magnesium powder was added to this solution of sulfuric acid. First of all, calculate the number of moles of magnesium and sulfuric acid that react. He's given me information about both reactants. That means I need to get the number of moles of each one and determine which one was excess. That's what we're trying to do. So I have 5 grams of magnesium. That means the number of moles is mass over molecular mass, and that means I have this number of moles of magnesium. Then I have information about sulfuric acid. The number of moles of sulfuric acid is this number. And then I need to compare in the equation. In the equation, the number of moles should be the same. They should be equal. So if I have 0.02 of magnesium, that is way too much to react with 0.005. So that means that the magnesium is excess. And that means what will happen is the number of moles of sulfuric acid that will react is 0.005, but that is also the same as the number of moles of magnesium that will react. So out of the 0.02, only 0.005 will react because the equation wants equal number of moles. Then the results obtained are given, and he has a table and he's telling you to draw the graph. Notice that he added the magnesium at time 2 minutes. So I plot the graph with x's, and then at 2 minutes, that's when I added the magnesium. So I join, remember how we do this curve? We join until the time when I added the reactant, and I go up straight to intersect with the other points in order to have the maximum temperature rise. So this is the graph that you should have. And then he's saying calculate the maximum temperature rise. It is from the highest point to the original where we started. So this shows a temperature change of 21.5 degrees Celsius. Please remember, this is how we do this type of graph, and they usually bring this a lot. Calculate the standard molar enthalpy change for the reaction. So we're trying to get delta H. But then what we need first is the Q. We know that Q is mc delta T. What is M? M is the mass of the solution. He tells me that he used 25 centimeter cubed of the solution. And we said that for a solution, the volume is the same as the mass in grams. So 25 is the mass that I will use, times the value for C is always 4.18, times the temperature change that we calculated. That gives me the overall energy in joules. Then in order to get delta H is Q over N. So it is Q that we just calculated over the number of moles that we said reacted, which is 0.005. If this comes out in joules, if we started with joules, it comes out in joules. I usually need to divide it by 1,000 so that it is in kilojoules per mole. Remember, delta H needs a sign. How did I know it was a minus? Well, I look at what happened to the temperature. The graph that we just drew shows an increase in the temperature. Increase in temperature means the reaction was exothermic. That means its delta H is negative. The negative is very important. This question is about the forces between molecules and ions. So he gives me information about fluorine molecule, hydrogen chloride molecule, methanol molecule. As you can see, the fluorine has very low boiling temperature, hydrogen chloride is higher, and methanol is higher. And he's saying, explain the large variation in boiling temperatures given the small range in MR. They are, all three of them are almost the same MR or very close to each other. So detailed descriptions of the forces are not required, but we need to say why the fluorine has much less boiling temperature than hydrogen chloride, and the hydrogen chloride has much less boiling temperature than methanol. Well, let's look at fluorine. You should realize that fluorine is a simple molecular structure. It has only weak London dispersion forces between the molecules due to the induced dipoles. So this needs a very small amount of energy to be broken. This does not have any other interactions except the weak London dispersion forces. But if we look at HCl, well, HCl is different. HCl, chlorine, is more electronegative than hydrogen. So we already have a permanent dipole-dipole interaction because the molecule is polar. And this is a stronger interaction than the weak London forces. So more energy is needed to separate these molecules in HCl. Now, when we look at methanol, now what is the difference? In the methanol, we now have hydrogen attached to a very electronegative element. It has stronger hydrogen bonds. Remember that the hydrogen bonds are stronger than permanent dipole-dipole, and the permanent dipole-dipole interactions are stronger than the weak van der Waals forces. So methanol will still have weak London dispersion forces. It also has permanent dipole-dipole, and in addition to that, it has the stronger hydrogen bonds, which will need much more energy to be broken to separate the molecules. Here he's saying calcium chloride is soluble in water. Complete the diagram to show how water molecules interact with each ion. You may use this sign to represent a water molecule. Remember, first of all, that we said calcium chloride is ionic. All ionic compounds dissolve in water because they interact with the water molecules. Now, if he says this is the sign for water, you remember that water is one oxygen and two hydrogens. The oxygen is electronegative, so the oxygen has a slightly negative charge and the hydrogens have a slightly positive charge. So these will surround the positive and negative ions, but the positive ions will be surrounded with the water pointing towards them from the more electronegative side. So it is the oxygen that will be pointing near the calcium positive ions, and it is the hydrogens, which are slightly positive, that will be pointing to the negative chloride ion. Explain why bromine is a liquid, but iodine is a solid. Again, if we're looking at the halogens, as we go down, the molecule becomes bigger, more electrons. So as we go down, the boiling temperature increases and they change from gas to liquid to solid. So if we're comparing iodine and bromine, iodine is a larger molecule with more electrons, so stronger London dispersion forces between the molecules, and this will need a higher temperature to separate the molecules. This question says magnesium oxalate decomposes on heating to form magnesium carbonate and carbon monoxide. A 6-gram sample of magnesium oxalate was heated for 3 minutes, but the decomposition was only 70% complete. Calculate the total mass of solid that remains. Remember, he's asking for the total mass of solid that remains, not just the mass of magnesium carbonate. So first of all, he says 6 grams of magnesium oxalate. So the first thing I need to do is get the number of moles. Number of moles is mass over molecular mass. Well, the molecular mass, I can calculate it. This comes out to be this number. So I can get the number of moles of magnesium oxalate that I'm starting with. So that comes out to be this number of moles. And then looking at the equation, you can see that the number of moles of magnesium oxalate is the same as the number of moles of magnesium carbonate. So I can get the mass of magnesium carbonate that would be formed. So it seems from this calculation that I will get 4.5 grams. Remember, this 4.5 grams is if there is total decomposition. But then he says it's only 70% complete. That means actually I will get only 70% of the 4.5. So the mass of magnesium carbonate that I will actually get is 3.15 grams. Now, since the magnesium oxalate decomposed only 70% of it, then I have decomposed only 4.2 grams, and that means I am left from the 6 grams that I started with, I'm left with 1.8. And that means in the end, I end up with what? I end up with 3.15 grams of magnesium carbonate and 1.8 grams remaining from the magnesium oxalate that did not react. So the total mass of solid remaining is 4.95 grams. Then he says, in practice, magnesium carbonate also decomposes on stronger heating. Describe and explain the trend in thermal decomposition of group 2 carbonates. Okay, what happens when we go down the group and we're heating the carbonates? Remember that going down the group, the radius of the metal ion increases, more shells, charge density decreases as we go down, the polarizing power of the metal ion decreases, and there is less distortion of the electron cloud of the carbonate ion. So weakening of the CO bond in the carbonate ion decreases. So for example, if we have magnesium carbonate, it will decompose more easily while the ones at the bottom of the group 2 will be more thermally stable. So just why a pure sample of magnesium carbonate will not be produced from the decomposition of magnesium oxalate even if the sample is heated for longer. This is because if you heat the magnesium oxalate, okay, it breaks down to give magnesium carbonate, but then he said the magnesium carbonate could break down as we continue heating, so I will not be able to get a pure sample of the magnesium carbonate because the magnesium carbonate will begin to decompose and form magnesium oxide. Then this question says phosgene is a colorless gas used in the pharmaceutical industry. Phosgene has a boiling temperature of this and is extremely toxic. Complete the dot and cross first of all. So if we look at this, how are we going to complete the dot and cross? First of all, the chlorines have 7 electrons in their outermost shell. They each need only 1. So we're going to share between the carbon and each chlorine 1 electron, and the chlorines have the rest of their 7. Then looking at the oxygen needs 2, so it will donate 2, and the other carbon will share 2. So we have a double bond between the carbon and the oxygen with 4 electrons being shared, and we have the rest of the electrons that are around the oxygen. Please practice all of this. Phosgene can be formed from carbon monoxide and chlorine using a catalyst of activated carbon. State and explain. So this is a reversible reaction, and he's saying state and explain how the reaction conditions could be changed to maximize the yield of phosgene. So we're talking about the change in the point of equilibrium in order to get more phosgene. Now, looking at this, what conditions can we change? Remember that in order to change conditions, we can change temperature, we can change pressure, we can change concentration of reactants. So let's say temperature first. In order to determine whether I should increase the temperature or decrease the temperature in order to get more yield, I look at the delta H. Is it exo or endo? The forward reaction is exothermic, so I need to decrease the temperature in order for the equilibrium to shift to the right or to give more COCl2. What about pressure? Well, pressure, we don't look at what is exo or what is endo, we look at the number of moles of each one. So I can see that going forward to form more phosgene, I will get less number of moles. To get less number of moles, I need to increase pressure. So increasing pressure will shift the equilibrium to the right, or we cause the reaction to go forward to give less number of molecules. What about the concentration of reactants and products? Remember that if we remove the product as it is formed, or if we add more of the reactants, this will force the reaction to go forward, and this will give more of the product. Then he says the standard enthalpy change of formation for phosgene is this. Complete the Hess cycle and determine the standard enthalpy change of formation of carbon monoxide. So first of all, we're looking at formation, so we need the one at the bottom here to be the basic elements, and we need the arrows to go up. So remember that the elements in the box at the bottom have to be in their standard state. So we have carbon in its solid state, standard state, chlorine is a gas, and oxygen is a gas, and we need only 1 oxygen in the product, so I have half of the O2. So this is the basic Hess cycle. But then he says, he gives me what? He gives the delta H for phosgene, formation of phosgene. So it is that arrow going up on the right, that is the formation of phosgene from its elements. So he gives me that number, minus 220.1. And we have the data from the previous question that this reaction, its delta H was minus 107.6. So what we're trying to get is the other arrow on the left, which is the delta H of formation of carbon monoxide. So going from carbon monoxide minus 107.6, this is equal to the other arrow. We can calculate for the delta H that we want, and that comes out to be this number. Then he says the mass spectrum of a sample of phosgene is shown. Give the reason for the ratio of peak heights at M over Z, 102, 100, 98. So he has 3 peaks at the end. He has 1, 4, 102, 100, and 98. What do you think? Remember that phosgene is COCl2. So this is something that has 2 chlorines. So either both chlorines are the ones with a mass of 35, or one of them is 35 and the other is 37, or both of them are 37. And remember that the ratio of abundance of the 35 to 37 is 3 to 1. So for these 2 chlorine atoms, the ratio of these peaks is 9 to 6 to 1. Remember that this was the mass spectrum that we discussed in Unit 1. Then he says, suggest an identity for the peak at 63. What is the peak at 63? If you look at this, with just one chlorine that is 35, that will give you 63. Draw on the mass spectrum the peak at 65, showing its relative intensity. Well, the peak at 65 should be about 30% of that original base peak. Use your data booklet to suggest the wave number of a strong absorbance you would expect to see in the IR of phosgene. Remember that phosgene is something that has a C double bond O, so you should have a strong band for C double bond O. And if you look at the data booklet, the band for the C double bond O here should be in this range. So you get that number from the data booklet, 1630 to 1850. Then he says, in UV light, trichloromethane reacts with oxygen to form phosgene and hydrogen chloride. Write an equation, and he doesn't want state symbols. So what we do is the trichloromethane plus oxygen to give the phosgene plus HCl. Do not forget to balance. If any equation has to be balanced. In a closed bottle, the rate of this reaction decreases with time. Of course, if the bottle is closed, then if the oxygen is used up, there is no more oxygen going in, so the rate will decrease. Suggest a precaution that should be taken when opening a bottle of trichloromethane. You should realize that this will give phosgene. He said phosgene is poisonous, very toxic gas, so we need to do this in a fume cup. Trichloromethane can be used as an anesthetic. Suggest whether an old bottle of trichloromethane can still be used. Well, if we have an old bottle, then it will probably not be very useful because it may have reacted with oxygen to give phosgene, which is very toxic, so I cannot use it as an anesthetic. And that's the end of this paper. I hope this was useful. Thank you for listening.